So, after one of my previous videos, I've been getting a lot of questions that are like, but Reese, how do we know that math is real? I'm dumb. Along that kind of thing. And I'm not judging the people asking these questions for being stupid. But instead, I'm going to, go through and I'm going to explain why math is right. So we're going to start very, very basically. How do I know that 1 is 1? Well, let me tell you how I know that 1 is 1. There is one of these because I have determined that that is what 1 refers to. 1 refers to a quantity, a single quantity, which is this. This is 1 because I say this is 1. All right, cool. Now what's 2? Well, 2 is if I have one of these, right? And then I add in a second one. 1 plus 1. 1 plus 1 is 2. All right, 1 plus 1 is 2. What's 3? Well, 3 is going to be if I have, hold on 1 second. All right, 3 is going to be if I have one of these. Well, no, 3 is going to be if I have 2 of these. 2 of these, right? And then I add in another one. So now I've got 3 of them, right? And so on and so forth. That's how we're going to define those. So we've got that pretty well established at this point. So now that we know that 1 is 1 and 2 is 2 and 2 is 1 plus 1 and 3 is 2 plus 1, and then so on and so forth. Give me 1 second to write that out, right? So now we have this. I even added in 4, just to be nice. So we have what all of these are. I know that that's all those, okay? Because that's how I defined them. But now you may be asking, well, we've said that 3 is 2 plus 1. But how do I know that 3 is 1 plus 1 plus 1? How do I know that's the case? Well, super simple. So we say that 3 equals 2 plus 1, because that's how I defined it. I know that 2 equals 1 plus 1. I'm not changing the 3 because that's still the same thing. The 2 I can say is 1 plus 1 because that's how we defined what 2 was earlier. And now I can add on another extra 1 there. Now, why can I ignore these parentheses? Because again, if we go back to that original example with the Tide Pods, it doesn't fucking matter. Just think about it. Don't be an idiot. Doesn't matter. So therefore, this is also equal to 1 plus 1 plus 1. So there, proved basic math. Very simple stuff. Now maybe you're saying, what about, multiplication? What about multiplication? Maybe that could be wrong. Because now I've shown that addition isn't wrong. Because addition, at least on this very fundamental level, addition isn't wrong. And if I can do it on this super, super basic level, it can be proved at the higher levels and someone else has done it. I'm not necessarily going to take you through those higher proofs, but, at least not in this video. So what about multiplication? How do we know multiplication works? Well, again, it's going to come down to how we define it. So we're going to define multiplication as just a series of addition principles, right? So like 3 times 1, we're saying is just equal to 3 plus itself 1 time, which is just 3. 3 times 2 is going to be 3 plus 3. So how do we know that 3 plus 3 is 6, which is, what we say 3 times 2 is? Well, that's going to be super simple, but, I know that there's going to be someone out there who's going to be like, oh, but how do we know? So I'm going to walk you through it, all right? All right, so we got that 3 times 2 equals 3 plus 3, because, again, that's how we defined multiplication. So now we're going to say, okay, well, what is 3 plus 3? Well, 3 plus 3 is the same as saying 3 plus... Now, again, we figured out that 3 can be 1 plus 1 plus 1, so I'm just going to go ahead and do that right now. 1 plus 1 plus 1 plus 1. All right. So now we have that, right? So what is 3 plus 1 plus 1 plus 1 plus 1? Well, we can say it's 3 plus 1 plus 1 plus 1. Again, because we figured out these parentheses, at least when it comes to addition, don't really matter because, why would they? Don't be stupid. So, what is 3 plus 1? I don't know. Oh, except for the fact that we defined it. All right, so that means it's going to be 4 plus 1 plus 1 now. Okay, what's 4 plus 1 plus 1? Well, 4 plus 1 is going to be 5 plus 1. 4 plus 1 plus 1 is going to be 5 plus 1 because, again, I didn't write out the exact definition, but, again, that's how we defined it. So we got 5 plus 1, and then that's going to be 6. So now we know that 3 times 2 equals 6. And again, I'm doing this at a very basic fundamental level. You can do this at higher level. I'm not necessarily going to take this through all these. So now the cool thing about this is you can do this for let's say I don't want to keep doing this with ones and whatnot. So let's say I'm going to set something equal to it differently. So let's say I want to do x equals 1, right? So now I'm saying x equals 1. Will it still work even though this 1 doesn't mean it's 1? What if originally instead of making up the word 1, I made up the word x and that's the symbol that I chose for it? All right, well, whatever. I'm going to be using some basic math ideas that we know here. So x equals x. Sorry, my bad. X equals x. Cool, got it. In the case of 1, x equals x squared, because, again, you're going to have to trust me on a little bit of this because I don't want to have to go through and prove everything. I swear to God, if someone questions me about this, I will go through and do it. So x equals x squared, right? If x equals x squared, I can subtract 1 from both sides. So it's x minus 1 is equal to x squared minus 1, right? Same thing, I'm still doing it. I'm now even mixing my two definitions of what 1 is. Will it still work? Yes. So now we're going to say x minus 1 is equal to, again, we know, because I'm assuming that you know, the principle of a difference of two squares. So it's going to be x plus 1, x minus 1. Again, real basic stuff here. You guys got this. I'm not going to go through and prove out all this because I'm lazy, but you're going to have to trust me. All right, so now I can divide and cancel out these two sides, right? And so that means that 1 is equal to x plus 1, which obviously, if we translate that out, it's going to be 1 equals 2.